My name is Taylor. I go by Polus Arcticus online. For the Starknet Winter Hackathon, I did Scarab Sign, an NFT marketplace hyperstructure that utilizes permit chaining to achieve efficiency. Permit chaining is a unique type of metatransaction, a multiplayer metatransaction that combines the sign type data of multiple different parties to be consumed at one time to perform logic on-chain. Contrary to a typical on-chain auctioning system, where an auctioneer deposits their NFT into escrow, an auctioneer on Scarab Sign simply signs an off-chain message that confers the intent to make an auction. A bidder listens on the pub sub queue for auction intents and enters the auction room. Now, instead of depositing their tokens into escrow, they too will sign an off-chain message that confers the intent to bid. The auctioneer will wait for bids to come in, and when they have enough or the deadline is reached, they'll execute the consume auction function on chain. This function wraps all of the bids, all of the auctions into one big multiplayer metatransaction. The contract will then go from highest to lowest bid and optimistically attempt to make the swap. Now, there's no obligation for a bidder to keep their coins in the contract. So if one is dishonest, it'll move to the next highest and then to the next highest. Future extensions of these contracts can include reputation systems. So if a bidder is dishonest, the reputation will get docked. Now, unfortunately, I couldn't figure out the signing of or shimming in this complex object into Starknet.js, but let's turn over into SN Forge to see it in action. Here we are in the SN Foundry repo. We find the test suite running against the Scarab Sign smart contract, the consume auction function. We find the signature snowball being checked against the auctioneer's signature. We do some replay protection and some minimum bid logic. And if the bid is by the bidder and the bidder has the right amount of tokens and the auctioneer has the right amount of bids, we'll get a successful auction. Now, we do get computational speedups with Starknet over Ethereum. We want to do this on Starknet, though, to enable anonymous big aggregation. So we use the homomorphic property of the Pedersen hash behind a commit reveal scheme, and we fragmentize the bids. And so you just see 25 or 34 in the queue, but after the commit reveal scheme's done, we agglutinate all the bids, and then we see the highest bidder. Not so obvious why an English auction would benefit from this, but for second price Dutch auctions or Vickrey Clark Rose mechanisms, the type of auctions that are economically efficient but pretty complex to do on chain, we'll see a real sweet spot here, and what I'd be hoping to extend for at Denver. So thank you for watching.